Let's now do a practice problem. Suppose the time interval between two consecutive defective light bulbs from a production line has a uniform distribution over an interval from 0 to 90 minutes. Find the mean or the average of the time interval. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here we are dealing with a uniform distribution. If X is the time interval between two consecutive defective light bulbs, it says it follows a uniform distribution with A equal to 0 and B equal to 90 minutes. Part B of the question is asking for the average of this distribution. The average of this uniform distribution we know is B plus A divided by 2, which is 90 plus 0 divided by 2, which is 45 minutes. Let's now see the part B. What is the probability that the time interval between two consecutive defective light bulbs will be exactly 10 minutes? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So again, we are dealing with a uniform distribution with A equal to 0 and B equal to 90. So X is a uniform distribution with 0 and 90. What we are looking here is the probability that X is exactly equal to 10. Well, this is actually equal to 0. And this is not only true for the uniform distribution in this example, it's actually true and correct generally for any other continuous distribution. If X is a random variable, a continuous random variable with any distribution, the probability that it be exactly one value is 0. And to put it in perspective here, we can actually use the plot of this distribution. So suppose this is 90, and this rectangle here between 0 to 90 is our distribution. This is f of x here, and here it's equal to 1 over b minus a, which is 1 over 90. So the height is 90 here. Okay, so the probability of x equal to 10, it means the area of this rectangle here. So suppose this is 10, this is 10. So the probability that x is equal to 10 is this rectangle here with a base equal to 10 minus 10, which is 0. So it has no base, and the height is 1 over 90. Height 1 over 90. Why the base is 0? Because it's just one point. It's 10, right? It doesn't have any length. It's just 0. So the base is 0 and the height is 1 over 90. So the area of this rectangle, which if you can call it rectangle, which is not, it's just a line, a vertical line, is 0. So that means this probability is 0. The probability that x is equal to 10 is 0. Actually, the probability that x is equal to any value is 0. 10, 9, 80, any value, the probability is 0. And again, this is true for any distribution, for any continuous distribution. If x is a random variable, a continuous random variable, so if x is continuous, is a continuous random variable, then the probability of x equal to any value is 0. following question for the problem. So we have a random variable that follows a uniform distribution with range between 0 and 90. What is the probability that the time interval between two consecutive defective light bulbs will be less than 10 minutes? Please pause, work on this problem, and then come back to see the solution. Let's see the solution. So here we have a uniform distribution. A is 0 and B is 90. What we are looking for is the probability that X is less than 10 minutes. So we can solve this using the integral, or we're going to go easy way, which is using the plot. So let's go using the easy way, using the plot. So X is here, f of X is here, and our rectangle would be, the plot of our rectangle would be here. This is 90 and this is 0. The height here is 1 over 90. What we are looking for is the probability that X is less than 10. Suppose this is 10 here. So what we are looking for is this shaded area of this rectangle. This is the probability that X is less than 10. What is the shaded area? The area of the shaded blue area, that's height multiplied by area is equal to height multiplied by base. What is height? The height is 1 over 90. And the base is 10. So the probability, or the area, is 10 multiplied by 1 over 90. Which is 10 divided by 90, and that's 11%. So the probability is 11%. Let's see the next question. There is 70% chance that the time interval between two consecutive defective light bulbs will fall between which two values that are the same distance from the mean? So here we have the probability, and that is equal to 75%. What we are looking for the two values here. Suppose I'm going to call this x2 and x1 here. So what is x1 and x2, in which the probability that x falls between x1 and x2 is 75%, and x2 and x1 are the same distance from the mean. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So what we are looking for is x1 and x2. We know the probability is 75%. x2 here. And x1 here. So to solve this, I'm going to plot our distribution, the rectangle here. This is 90 here, 0 is here, and the height is 1 over 90. So it says x1 and x2 are the same distance from the mean. So we need to find mean first. What is the mean of this distribution? For the uniform distribution is a plus b divided by 2, which is 0 plus 90 divided by 2, which is 45. 90 divided by 2, which is 45. So I'm going to find 45, which is in the middle here. So that's our mean. And x1 and x2 are the same distance from the average mean here. So suppose x2 is here, and x1, the same distance on the left, is here. This distance, x1 to average, 45, is the same distance as this distance from x2 to average. And I'm going to call that distance whatever it is. We don't know what it is. It's d. I'm going to call it d. So d here on the left and d on the right. So we know that the probability that the x between x1 and x2 is 75%. That means that the area here between x1 and x2, this area is 75%. So what is the area of this rectangle? The area is height multiplied by base. Height is 1/90 multiplied by base. What is base? Base is 1d here and 1d here. So the base is 2d, 2 multiplied by d. So we know that this is equal to 75%, right? The area is 75%. With this, we can solve for d, and d would be equal to 33.75. All right, now that we have d, finding x1 and x2 is easy. x1 is on the left of mean, that means 45 minus d, and x2 is 45 plus d. So x2 is mu plus d, which is 45 plus d is 33.75. That's 78.75. So that's x2, and x1 is mu minus d. And that's equal to 45 minus 33.75. And that's 11.25. So we have x1 equal to 11.25 and x2 equal to 78.75. This is x1 and this is x2. Next practice problem. How long does it take for you to download a game for your iPod? According to Apple's technical support site, downloading an iPod game using a broadband connection should take between 3 to 6 minutes, assuming that the download times are uniformly distributed between 3 and 6 minutes. If you download a game, what is the probability that the download time will be less than 3.3 minutes? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here we have a uniform distribution. X is the download time. It follows a uniform distribution with A equal to 3 and B equal to 6. So what we are looking for is the probability that X takes less than 3.3, the download time. So the probability that X is less than 3.3. We can use the integral to solve this, or we can use the plot of the data. So let's go ahead and use the plot of the distribution to solve this. So this is the plot of the distribution between 3 and 6. Suppose 3 is here and 6 is here. Then suppose this is going to be our rectangle, and the height of this rectangle is 1/6 minus 3, 1/b minus a, which is f of x equal to 1/6 minus 3, which is 1/3. So the height here is 1/3. What we are looking for is the probability that x is less than 3.3. Suppose 3.3 is here. So basically we are looking to find the height of the area, the shaded area, green area here. This would be the probability that x is less than 3.3. The area is height multiplied by base. Height multiplied by base. Height here is 1/3, and base here is 3.3 minus 3, which is 0.3, multiplied by 0.3. So that gives us the probability, which is 0.1. Next question. What is the probability that the download time will be less than 4 minutes? So please pause, work on this problem, and then come back to see the solution. Let's see the solution. So again, if you go with the plotting and finding the area is much easier. The plot of the area for this problem would be, so we have the probability that x is less than 4 minutes. It would be finding the area here. This is 3 and 6 originally, and our problem is less than 4. Suppose 4 is here. This is 4. So we are looking for the blue shaded area here. The blue shaded area, the base is 1, 4 minus 3, which is 1, and the height is 1 over 3. So it would be 1 over 3 multiplied by 1, which is 1 over 3, which is 33%. Next question. What is the probability that the download time will be between 4 and 5 minutes? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here we are looking for the probability that x is between 4 and 5. Again, you can plot this distribution and find the area of the rectangle between 4 and 5. But you don't really need to, because it would be, you can imagine it that it would be a rectangle with a height of 1 over 3 and a base of 5 minus 4, which is 1. So again, that's 33%. Next question. What is the mean and the standard deviation of download time? So please pause, work on this problem, and then come back to see the solution. Let's see the solution. So the mean of uniform distribution, if you have a uniform distribution with A and B, we know that the mean is A plus B divided by 2, and the standard deviation is B minus A squared divided by 12 is square root of this value. Here B is 3 and B is 6 and A is 3. So we're just going to plug in the values. So the mean is 3 plus 6 divided by 2, which is 4.5. So the expected or the average waiting download time is 4.5 minutes, and the standard deviation is 0.87 minutes.